One.
Hi, Steve Miles, General Manager of Analtech. We're here at Pittcon in Orlando, and what I'm holding here is one of the smallest plates that we make, thin layer chromatography plates, 2.5 and 4. When we're a little bit slow, we take a look around at our neighbors and we think, what could we do with some of these people's products? And right across the booth from us is a company called Dino-Lite, and we're going to go over and talk to Joe and see just what he can do with our digital microscope. How you doing, Joe?
Hi, Steve. You on?
Hi. I've been looking across the booth for the last couple of days and seeing just how new people the digital microscopes are. So you have one of our plates under there. Here's some of the capabilities you have.
Yeah, I was just taking a look at this. Well, I can get some magnification of up to 230x on this.
Okay. I see you've got our dye separated up there looking pretty good.
Yeah, this here is really not under too much magnification, but we can always get closer.
Okay.
And we could photograph this. And we could do some image analysis, measurements, and things like that.
Okay. What I'm really curious about is, can you turn that plate on its edge and actually see the silica gel and the glass and maybe even determine the thickness of the silica gel on the layer?
Well, it depends on how thick that layer is, but let's take a look. Okay, so I'll take my Dino-Lite digital microscope here. Go to a little bigger screen. I'll just focus in on that layer.
Wow.
Well, I'm almost there. I can go much further than that. Let's take a look. All right here we're at approximately 200x magnification.
Okay.
And what I'll do is just snap a photo of that, which I've done. Now what I'll do is take a look at that image that I just captured. And here it is. And I'll double click to open that image. And here's the captured image.
All right.
So what I'll do now is take a look at my scale to determine the magnification.
Okay.
And that will allow me to create a point of reference for measurement purposes. So I go and I input that magnification into the captured image. I expand the screen as much as I can. It makes it easier to measure.
Okay.
Now, Steve, what kind of units would you like to measure this in?
Microns would be perfect.
Okay. So that's a pretty thin layer. So I better use a pretty skinny line. Okay, I've got it skinnied up. We'll do a line measurement. What I'll do is initiate by clicking.
Wow, that is cool.
And then I pick my termination point. It is a rough edge, so I have to kind of estimate.
Mm-hmm.
And there we go. We have a measurement of approximately 150 microns.
And that's pretty much dead on for this actual layer that we brought with us.
Well,
very, very good.
Since we have an uneven layer, what I would do is probably take a series of measurements and then do an average. So now we're at 161 there.
Okay.
Now I am at about 144 here. And it all depends on the operator picking, initiating, and terminating the measurement.
Okay.
Again, it's a nice smooth layer, but under magnification there is a little bit of roughness. So I have to pick my high and low point.
Very good. Very good.
Now I can save the measurement, keep them with this image. Use the image, directory file, and open it again, and you'll see that those measurements are still captured in that image.
Okay. I think our technical director, Ed Dugan, would love to have a tool like this in his lab. Can you show us some of the other applications that you work with?
Well, we work a lot with electronics and general quality assurance, industrial. Scope is very popular in the law enforcement industry, forensics,
Okay.
etc. Counterfeit identification. Basically, anytime magnification is required, this is a very handy tool.
So when I was watching CSI last night, they were zooming in on the body of the mosquito and then trying to take a sample from it. They were probably using something like this.
They probably were. In fact, entomology is one of our more popular markets.
Okay.
And you'll see this particular scope has polarization, so I can control glare. We also use this in dermatology. Here we'll
Oh, yeah.
this is all 50 times magnified on my skin. Now when I polarize this, I'm actually able to get some penetration. And of course I can just continue and dial in, manually dial in my magnification. And right here we have about 200x.
Okay.
Electronics is very popular in the electronics industry. General inspection, soldering, micro solders, micro welding inspection. Aerospace industry. We have these in NASA. Now I'm going to polarize that.
What's the lighting source you use? Is it like LEDs in there? Or?
Yeah, we have a built-in LED ring light,
Okay.
which can be turned on and off. And external lighting can be used as well. And then we have a variety of different models, including UV and IR, as well as a line of eyepiece cameras that standard microscopes, section scopes, and other types of scopes, including telescopes. It's just a matter of working distance, and as you change the working distance, you just bring it into focus. Very versatile tool, and as you saw, it has the calibratable measurement features as well as real-time image editing features as well.
Excellent.
And they're affordable.
Okay. Yeah, $400 sounds very affordable. Thanks a lot, Joe.
All right, thank
Great
you.
meeting you.